Welcome to our lesson on the multiplication property of equality and proportional relationships. Please make sure that you have a piece of paper and a pencil because there's quite a bit of writing for this lesson. If you need to pause the video at any time because there is a lot of writing, please go ahead and do so. Please make sure you have the title of today's notes written out. All right, so I do want you to write out what we have up here, the proportions up there. You don't need to write out the questions that I wrote out in red though. So what this says is, what do you notice when you simplify the first set of ratios? Well, let's go ahead and do that. If I were to simplify this, sorry about that. If I were to simplify this, what it would end up showing is that 3/4 equals, and then 9/12 also reduces to 3/4, so it would say 3/4 equals 3/4. Same thing with the second set of ratios. If you were to reduce this, 5/10 reduces to 1/2, and 6/12 also reduces to 1/2. So basically what this is showing us is, even though these numbers look different, 3/4 looks different than 9/12, 5/10 looks different than 6/12, they are actually equal to each other, which is why there's an equal sign in between. Okay, what do we notice about their cross products? So let's go ahead and erase their simplified versions. You can keep it on your paper, but just on my paper. Cross products means the ones that are across from each other, the parts of the ratio that are across from each other. So the product of 4 and 9 is actually the same as the product of 3 and 12. And I know this because they're both equal to 36. So if I were to reduce that, 4 times 9 is 36, 3 times 12 is 36. So this times this is 36, this times this is 36. Let's check it on the other side and see if it still works. So 6 times 10, we're hoping that it's equal to 5 times 12. And when we work that out, 6 times 10 is 60, and 5 times 12 is 60. So what we know is that if there are two ratios that are equal, their cross products are also going to be equal. So I want you to write that out on your paper. So the cross products of equal ratios are equal to each other, are equal. Now, we are going to stop using the phrase equal ratios, and we're going to start using the word proportion. A proportion is two equal ratios. So just to sum up what you should have on your paper, you should have any math writing that we've already done. You should also have this note that the cross product of equal ratios are equal. You should also have this definition of a proportion, two equal ratios. And now we have the multiplication property of equality that we're going to talk about. We've talked about the multiplication property of equality before, but in this case, what we're referring to is that the cross products in a proportion are equal. Okay, so that was a lot of writing to do right there, but now we've got most of our writing parts done, and we're just going to do some math. So if you need to pause this just to get all that writing down, go ahead. Okay, we're going to use our knowledge of cross products to solve these problems. It says 2/3 equals 8/something. Now, if these ratios are equal, what that means is that their cross products are also going to be equal. So this times this is going to be equal to this times this. So one way you could look at it as 8 times 3 is 24 is going to be equal to 2 times x, which is 2x, and then you would divide by 2, and you would find out that 12 equals x. So you would find out that your answer there that you were looking for was 12. Now, when we solve a proportion using cross products, I call it the multiplication fish. I start over here in this top corner. I multiply this side times this side. So I show my work, 8 times 3. And then I set it equal to, since we know that cross products are equal, so equals 2 times x, which is 2x. So then I can reduce. 24 equals 2x, divide by 2, and divide by 2. 12 equals x. Now, some of you might be wondering, do I need to show all of that work? I'm going to go ahead and say yes. There are not going to be problems that are this basic. These are things that you've learned last year in 6th grade. We're just reviewing. Our questions are going to be a lot more complicated, so you will need to show the proper work, showing that you're cross multiplying and setting them equal and things like that. Okay, the next problem is a little bit more complicated because it involves a negative. So what we're going to show here is that it's x over 2.5 equals negative 3 over 4. Okay, we moved the negative to the top. Now, we know that our answer for x should be negative because if the right-hand side ratio, negative 3/4, is a negative value, the left-hand side also has to be negative if they're going to be equivalent, which is represented by my equal sign. So let's go ahead and use our multiplication fish or our cross products. Negative 3 times 2.5 is negative 7.5. Then we need to place an equal sign because the multiplication property of equality tells me that the cross products are equal to one another. X times 4 is 4x. So now, using a calculator, I can divide both sides by 4 here and here. Negative 7.5 divided by 4 is negative 1.875, and then we're going to say equals x. Now, we do need to make sure that we're not rounding any of these. If you round, it's not going to make the ratios equal or the proportions equal. One way to double check your work is to divide. So once you figure out what the answer is, you divide this number divided by this number. Now we know in our heads that negative 3 divided by 4 would be negative 0.75. But a good way to check the ratio is that when you divide this number, negative 1.875, divided by 2.5, it should be that same number. So when you check it in your calculator, it does actually work. It's negative 0.75, excuse me. Now in the top, if we want to use that same logic, 2/3, most of us know, reduces to 0.6 repeating. And if you were to divide 8 divided by 12, because that was our answer, you get 0.6 repeating. So if you were to convert both sides into just a decimal number, they should be equal to one another. All right, moving on to a simple word problem example. A box of cereal weighing 254 grams contains 20 grams of fat. Find the number of grams of fat in the recommended serving size of 55 grams. So this is saying the whole box total is 354 grams and it has 20 grams of fat. So if I want to just eat, not the whole box, but if I want to eat a serving size of 55, how much fat would that be? So what I'm going to do is I'm going to kind of code this with some colors. The serving size here that I'm talking about is 55, which kind of relates to the serving size of the whole box. And I want to know how much fat. Well, 20 grams of fat, that matches with this. And then how many grams of fat if we were to have the smaller serving size. Now, there's a lot of different ways to set this up. Okay, you could use a lot of different comparisons. You could compare the fat to the fat and set it equal to the serving size over the serving size, as long as you match them properly. You could do fat over serving size equals fat over serving size, as long as, again, you match them up properly. You could do something like serving size over fat equals serving size over fat, okay? whatever you do, as long as you match them up top and bottom, it will work. So let me show you 3 different ways that I solve this, and you're going to actually write out all 3 ways with the work. And I know that's a little bit of writing, but you do need to have these examples here. The first one I did was serving size over fat. Okay, so I did 354, which is the whole box, compared to the fat of the whole box, which is 20, equals 55, which is the serving size that I want to eat, over X. And what I found out was that the answer should be 3.1. Then I solved it again. This time I did something else. I did fat over serving size. So I picked the fat of the whole box, 20, and the fat of the serving size of the whole box, which is 354, and I set it equal to the fat that I'm going to be consuming in my serving size, which I'm not sure what that is, so X, over 55, and then you would cross multiply and get 3.1. And then there's another way you could do it. You could just compare the fat and the fat over the serving size and the serving size. You have to be careful to line everything up though. The fat is 20 compared to the other fat, we're not sure. On the top here, I had to put the fat the serving size from the box because it matches right across here. 20 and 354 match over the serving size that I'm going to eat, which is 55. So no matter how you set this up, as long as you set up the top and bottom matching and the side to side matching, you're going to get the correct answer. And you're going to see a video more about that later. Okay, using what you know about the multiplication property of equality, how could you solve the problem below? Basically, what you need to do is remember that we have our strategy of the multiplication fish. What you can do here is multiply this side times this side and set it equal to this side times this side. Now these problems are a little bit fancier than what we did before, but all you're doing is multiplying 5 times the quantity x minus 2 and setting it equal to 7 times the quantity of x plus 4. So again, here would be your first step. 5 times the quantity x minus 2 equals 7 times the quantity x plus 4. Then what you're going to do is just go ahead and distribute all the way through. Your next step would be to gather all of your variables onto the same side. So what I would do is subtract 5x from both sides. And then you need to get your regular numbers onto the other side. So subtracting 28 from both sides, you would get negative 38 equals 2x divided by 2. And you get negative 19 equals x. So if you haven't wrote that out yet, go ahead and please do so. Okay, go ahead and try this example by yourself. Press pause in the video and then we'll go through it together. All right, hopefully you used our strategy of the multiplication fish, which is really the proper name, multiplication property of equality. 5 times w plus 6 equals 3 times w minus 4. So we can go ahead and check that out. 5 times the quantity w plus 6 equals 3 times the quantity w minus 4. You have to distribute your 5 and distribute your 3, and then it's a regular multi-step equation. Okay, we would distribute, get all of your w's onto the same side. It doesn't matter which way you move it. Subtract 30, and then you would get your final answer, w equals negative 21. Now, if you had moved the 5w onto the other side, you would get the same answer, but remembering that it's okay if you had negative 21 equals w. It just depends on how you had set up your proportion. Okay, and one final example. Go ahead and try this, and we'll solve it together in a moment. So go ahead and solve it and then press pause. All right. Your very first step should be that you're showing that you are multiplying 35 times the quantity of y plus 4 and 7 times the quantity of y minus 15. From there, you can distribute, combine all of your like terms onto one side, combine your numbers onto the other side, and when you divide, again, you of course can use a calculator for this one. When you divide, you get y equals negative 8.75. And that's it for now. Thanks for watching.